Good afternoon, good morning, good evening, wherever you are in the world or beyond. Welcome to the Renewable Energy Institute's webinar today, looking at the future trends and how the renewable energy sector is shaping up in 2025 and beyond. My name is Alex Lewis-Jones. I'm going to be hosting today's webinar with a whole host of our amazing lecturers. We will get to meet them later on. What we're going to do is begin with introducing a bit about the Institute and what we're doing, then talk about the individual courses that we teach, and then we're going to explore a couple of questions on how renewable energy is developing so far and what we think the key trends are for renewable energy and renewable energy education going into the coming year. A couple of bits of housekeeping for you just to begin with. We are recording this, so if you want a copy, it will be distributed to you afterwards. That's often one of the common questions that people have. On the topic of questions, we do welcome interaction. So if you've got any burning questions for us, please put them in the chat and our team will elevate them to us and we'll try to get to as many of those throughout the webinar today. Okay, to kick us off, I just want to talk a little bit about the Institute itself. Welcome to all those who have been here before, have done some of our courses, but a very warm welcome to anybody who is not familiar with the Renewable Energy Institute. We're actually celebrating our 50 years. We've been going since 1975, being one of the leading global providers of renewable energy and energy efficiency training. So the Institute offers CPD accredited courses to participants all over the world. We have had participants in, I believe, over 150 countries now. And this is all delivered through collaborations with universities, government departments, industry experts like the ones you will meet on the webinar today, and the United Nations. We host the Galileo Master Certificate, the GMC, and this is globally recognized as one of the key pinnacles for training in the fields of renewable energy and energy efficiency. All our courses are available online and on demand, so you're able to study wherever you are in the world at whatever time you like. We do also have the option for courses in the live virtual classroom. So this is an opportunity where you can participate in the courses at the same time as interacting with lecturers and other people studying those courses. Now, if you would like any further information on this, we'll put some information in the chat for you, but just give us an email or we've got a UK number, give us a ring and we'd be glad to sign you up to a new course. Okay, that's the Institute. I'm going to ask our lecturers to introduce themselves. So what we're looking for is who you are, what your expertise is, and what courses you teach. I know for some of us, there's quite a few courses that you teach. So we'll just keep things quite quick so we can get a feel for who the specialists are in the room. If you are listening into this, my top tip is if you hear a particular topic in the specialities of our lecturers and you've got a question in mind that you've been wanting to get answered, put it in the chat now and we'll see if we can get to that later on. So I will go round the room based on how people are positioned on the participant list here. So it'll be John Clipsham, then John Wilson, then Rob, and then finally Marta. I will kick off. Hello, I'm Alex Lewis-Jones. I teach the electric vehicles course at the Institute. My background is a decade in electric vehicle transition, working with governments, working with major multinational corporations to work out what the strategy is to take an energy industry into a vehicle industry and watching how those two sectors are colliding. It's been really good fun. I've really enjoyed teaching on this course and also at the University of Edinburgh on this topic. So any questions you've got on the electric vehicle world, I'll be really happy to cover those throughout. On to John Clipsham.
Hi everyone, great to see so many people on the call. and I can already see one or two very familiar names who have either suffered or enjoyed the courses that I teach. I deliver 4 courses on behalf of the REI, based on a lifetime's experience in the hydrogen sector as a chemist and chemical engineer. It won't surprise you that the 2 big hydrogen courses we do, one on hydrogen energy and the second one on developing hydrogen energy projects, fall under my remit. 2 other courses that I teach, one is about renewable energy and finance, very focused on summary of all the different renewable technologies, and then drifting into the field of project finance, project structure, and how we can actually make these projects a reality. The final course I teach is a very high level overview course looking at the global energy transition and how we can deal with the impacts of climate change, how we can mitigate some of the carbon emissions that we're dealing with, how we can bring new technologies forward, and so on. And that's a very high level approach, focusing on things like ESG and some really in-depth case studies in there as well. So if you want to know anything about hydrogen, hydrogen energy, renewable energy finance, ask Alex.
Thank you. John Wilson.
Hi, yeah, great to see everybody. I've originally started in thin film photovoltaics in the early 1970s, and I think it's gone through about 3 different generations, and now, of course, it's a really dominant technology. But been involved in some off-grid design for Africa, development with UK and other manufacturers and prototypers, and we've also done some technology transfer into a number of countries. But it also led into a lot of materials research and using plasma processing to produce materials. But I've been giving the solar PV course since it started, really, in about 2008. So I've been doing that for some time, and it's developed into quite an intense course with a lot of electrical energy knowledge needed at the beginning, but we try to uncover that and take everybody up to the standard where they understand what's going on and how these things work.
Thank you. Rob?
Hi, my name's Rob Gwilym, and I've been working in the renewable energy sector for 35 years. Over my career as an engineer, I've covered a vast range of projects, from solar electric, hydro, wind, low energy buildings, all sorts of different things. And because of that experience, I've been able to teach around 10 courses for the Institute. There's a sort of introductory course, which is called Renewable Energy Solutions. And that is a quick snapshot and whiz round most of the renewable energy technologies. The other guys like John go into a bit more detail on something like solar electric, or a lot more detail on something like solar electric, but I just touch on that. But also things like energy efficiency and all of those others. So Renewable Energy Solutions is a sort of starter course, if you like. And then I have other courses like, for instance, biomass, which concentrates on heating systems and the uses of biomass as a renewable energy source. I've worked on some wind projects, and so I deliver the wind course, which is pretty intensive course on everything from the theory of a project right the way through the technology, right the way through to how a project is developed. And then I've also delivered the hydro course, and we cover wave power in that course, and some of the marine technologies as well. And that's been a very interesting course, because to date, things like hydro is a very established technology, and so there hasn't been much change in it for a long time. But recently, we've seen lots of interest in pump storage schemes, with some really big projects going ahead, and that sort of leads me on to the energy storage course, which I also deliver. And here we talk about pumped hydro, but also, of course, batteries. Not so much in their applications in the transport sector, but in the energy power sector. Finally, sort of more on the energy efficiency side of things, combined heat and power systems are systems which use conventional generators, or typically conventional generators, but the heat is recovered from them as well. And they're an important transition technology, but then they'll also become important in the hydrogen future as well, because if we're using hydrogen as an energy source, then recovering the heat from those processes can be, well, it can improve the efficiency very significantly. The other course that I deliver is the energy efficiency course, which is concentrating largely on buildings. And because of the work I've done in biomass, largely in the heating sector, I have a fairly good understanding of how low energy buildings are constructed and other energy efficiency technologies, because they always run in parallel with any energy project that you do. The first thing you do is you try and think, how can I use less of it, rather than just carrying on as business as normal. So energy efficiency is another important part of the courses I deliver. And I think I've done most of them, but the last one I can think of is solar thermal, where you're using the sun's energy to heat up fluids, whether that's for industrial processes or for space heating or just for hot water. And so we have a day on that as well.
Amazing. Thank you, Rob. I'll save my questions for the end, but I'd love to know how you find time to sleep and eat as well, because you're extremely busy with that catalogue there. Finally, Marta.
Thanks, Alex, and a pleasure to be here. I'm Marta Oliveira. My background is more on structuring decarbonization projects for large infrastructure, so airports, ports, logistics, waste and water sector. But really, that is about finding the right renewable energy solutions, and now looking at sort of additional natural capital, carbon removal, and sort of biodiversity opportunities for the assets. So I normally look at how these sort of innovative systems can be more bankable for investment to support accelerating funding into the net zero transition. I teach the courses on carbon finance and carbon capture and market strategies. Really, just briefly, these courses touch on how to best use carbon markets from a credit buyer perspective on the carbon finance course. So specifically how companies can achieve their net zero targets, how they even set those net zero targets, and how they comply with some legislation on reporting that's coming through. How can they use carbon markets to support them on their journey as well? And then on the carbon capture and market strategy side is more on the credit seller perspective. So it's for companies and entities that want to put together those carbon removal projects, and to understand what it means putting together sort of projects with high integrity standards, and how to get those projects sort of accredited and financed for carbon markets.
Fantastic. So, into our questions. We've got 2 questions to answer today, and they're huge questions. So I'll appreciate if we can be as succinct as possible with our thoughts and our answers. The first question is about the positioning of the renewable energy sectors so far. Okay. The reason that we're asking this is, 2025 has, for a lot of people in the sustainability and green tech world, has been quite gloomy so far, even though we're the first month in. There's been some challenging news about progress on carbon emissions targets and rollback on certain technologies. But we want to see, well, what's actually been the progress here. So I want to kick us off with just 3 little facts that I found interesting over the past week, and I'm going to pick on some people to take the conversation forward. The first fact, certainly in the EV world, all eyes inevitably end up on China. One fact I found really interesting, and I'm sure John or Rob might have a view on this, but I found it interesting that it took 10 years for China to install its first gigawatt of renewable energy. And then last year, in 2024, it was installing a gigawatt of renewable energy every single day. Or that's what's being expected. So that pace of growth, that exponential growth, perhaps, is fascinating. At the same time, we're seeing a plateauing in China's emissions from 2024. So there's been some good progress there. back to my world of transport, are we at peak internal combustion engine car? That's a question that a lot of analysts are asking at the moment because 2024 again saw us, after a period of rising demand for internal combustion engine vehicles, we've actually started to see it drop down, not because of a demand issue, but because they're being switched over to electric vehicles. So that's a really exciting point in the energy transition. Final point, bringing it back to education, there was a survey out over the last 10 days, I think, that in the UK, 71% of Brits want to change jobs to a green job, highest amongst youngest people. And the reasons for not being able to get a green job were either a perceived lack of the jobs being out there or just a lack of knowledge of these green technologies. So there's an exciting opportunity if you are in this space to help people get educated and start finding these new jobs. So I just want to kick us off there, and then I'm going to drop straight to John Wilson for your thoughts on the development of renewable energy thus far.
Yeah, thanks very much, Alex. It's interesting what's been released in the last few days, some positives, some negatives, of course. Solar PV, of course, is a very significant supplier of electricity at the world level now. And I summarised the position for the year 2023 in an article for the REI, and it appears on their Renewable Energy Insights for those who want some detail. But installations of photovoltaic range from rooftop residential all the way through to megawatt solar farms. And to meet this demand for solar panels, it's practically all come from China. The biggest producer and supplier of silicon and of cells and of panels is China. And it's not surprising, therefore, that they've got the biggest installed capacity of approaching 900 gigawatts at the end of 2024. But of course, there's a greater demand for electricity all around the world. And this is driving the expansion of photovoltaic as it is other renewable energies, not least, of course, for AI servers that are going to use large amounts of energy. They're not energy savers at all. And that's another consumption that perhaps we wouldn't have foreseen a few years ago. Just returning to 2024, solar PV accounted for something like 11% of the EU electricity, which was more than coal. So coal is slipping back for all sorts of reasons. And indeed, across the EU, I think almost 50% of power was generated by all the renewables. So it is making very large inroads. Just sticking with PV, the EU added about 66 gigawatts last year, 2024. So although it was way below China, it's still significant. And other countries are launching tenders for quite large systems now, ranging from Bangladesh, United Arab Emirates, Malaysia. They're all putting in requirements to have installers put in very large panels, arrays, and of course it goes with batteries and all the other part. At the moment, oversupply of Chinese panels is keeping the price low. That's unlikely to keep going forever. There are hints that the price might be coming up a little bit. You can't keep running an industry, even if it's state-sponsored, at a loss. And that, of course, is what has been happening. So where's that leading us to? Well, there are certainly expanding opportunities in photovoltaics across the world. That's for designers, installers, maintenance, operators. And just as Alex had said, there is a world demand for what they're calling green skilled employees. It's growing at about 10 or 11%, but the supply is only growing by about half that. So there are a lot bigger demand than there are at the moment people who are trained. Now that's a world scale, and of course it will vary locally. We'll come back perhaps to what the UK and Europe are doing later, but it does mean that you're likely, whatever country you're in at the moment, to have opportunities to be employed as long as you've got the skills that are being demanded. That's where I'll end for the moment.
Thank you, John. Rob, is there anything you'd like to add to that?
Well, yes, I mean, obviously, John has concentrated on solar because that's his, or solar electric because that's his area of expertise. But I think there are parallels in many other sectors, especially wind, where we're seeing not only large increases in deployment, especially offshore wind, but we're also seeing big increases in scale. You know, when the first wind turbine I put up was about 10 meters across, and now we've got machines which are 210 meters across, and so that technological change is carrying on, and it means that there are an ever more increasing demand for people. We're also beginning to see a shift in the manufacturing of wind turbines, which were predominantly European and American, and now the Chinese are becoming big players in that. Not only for that, once again, they've used their home market to grow their technological base, and now they're aggressively going into the Western economies. And so we're going to see change there. And the scale of machines has gone up, and what that has meant is that the reliability of the supply from wind has improved as well considerably, what we call the capacity factor. And that movement offshore as well, all of which is meaning that that sector is doing very well. I think at the moment there are something like 32,000 people employed in the offshore wind industry in the UK alone. And that's expected to grow to 88,000 by about 2026. So massive increases in that. And that's just for one country. We're beginning to see lots of countries which traditionally didn't really have an offshore wind industry, like Japan, parts of China, parts of the States, are also beginning to move into this technology because we're seeing the introduction of floating wind farms. So rather than having a foundation in the seabed, they're now floating, and they can put them pretty much anywhere where you like, as long as you can get the power out. Which brings us to the other interesting bit that's happening in the UK, which is and across Europe, is the way that everything's all interconnected. And how do you move this power, which is now generated in places which traditionally don't have a big demand, and get it to where the demand is? And you've only got to look at the news feeds in the UK to see there's lots and lots of money being spent on grid improvements, new interconnectors into other countries, and energy storage. And that has been a massive change in the UK as this move from adding batteries into the system, and the batteries are not only storing energy, they're also helping to replace the dynamics of conventional generators like coal-fired and gas-fired power stations. So they help to keep the grid stable. And as I was saying, we're seeing huge developments in pump storage in the UK, potentially up in Scotland, and all of these things are all interlocked together. And I think that's one of the fascinating and interesting places to be working at the moment, is how does it all stick together? Because we can say, oh, we're going to have wind, or we're going to have solar or hydro, pick the technology of your choice, but how do you glue it all together so it works as a reliable and consistent grid? And some of my courses discuss some of the issues there, especially energy storage. So generally, despite some of the downs that we've had in the last year, I think renewable energy is in a very good position, not least because often it is the cheapest way to generate electricity. And so, you know, Mr. Trump can do whatever he likes, but at the end of the day, onshore wind power is still the cheapest generator, and trying to deliberately stop the cheapest form of generation is not a good plan if you're trying to keep your energy costs down. So it will be interesting to see how all of that pans out for the United States. But in the UK and in Europe, that onshore capacity is beginning to plateau, but now we're beginning to see us replacing old technologies with new technologies. It's not quite there yet with solar, but it is there with wind, where we've had machines up now for 25, 30 years, and some of those machines are now being replaced with more modern, more efficient devices.
Great. Thank you, Rob. So yeah, economics will will always win out, right? So it's exciting to see all those different technologies develop. I'm just wanting to get a hydrogen perspective on that, John. Over to you.
Right, hydrogen perspective. I'm going to actually pick on one of the numbers that Rob used there. Were you saying, I think, 80,000 people now employed in the UK renewable sector, something like that?
Oh no, no. In the UK, it's 639,000. That was just offshore wind. It's at
Offshore wind.
32,
Okay.
and it's going up to
And
88.
apologies, this is a UK centric example.
Yeah.
The oil and gas sector employing 120,000 in the offshore world. You can see there that renewables is very, very rapidly catching up. And one of my experiences on the hydrogen courses has been we get a lot of people from the oil and gas sector thinking about their future, thinking about how can they reposition themselves in a world that is going to grow, in a world that is going to grow very, very rapidly and demonstrably so. And if we just add in another couple of numbers for you, as we like to have lots of statistics at the REI. Electricity use worldwide is growing at twice the growth of our energy demand. That's quite a scary statistic. And by 2030, we're expected to have 50% of global electricity generation from low emission technologies. So that kind of stacks up with that shift in employment away from traditional fossil sectors towards the renewable sectors. So that just a few more statistics there for you. One other statistic that I did come across, and I'll come to hydrogen in just a second, was we're currently spending for every dollar on renewable electricity generation, only 60 cents on energy storage. That, as we increase renewable energy penetration, and therefore the intermittency and availability of our electrons, because the majority of that new capacity is solar and wind, that means we've got to increase our energy storage capabilities worldwide. That can be through interconnection, it can be through the use of batteries, or it can be by the Planet PLC, our overall entity, taking finally the decision to push forward with hydrogen. Those of you that have done the hydrogen courses with me will know this. We've had 3 at least bites at this since the 1950s, where we've tried to get a hydrogen economy going. We're still on that cusp of making it happen, and I can see progress being made. 1 gigawatt of hydrogen generation, clean hydrogen generation technology deployed in 2023. We've now got 20 gigawatts at final investment decision. That's tiny in comparison to what we're going to need, what the projections are telling us. But we're now seeing that hockey stick exponential growth starting to kick in. And in fact, we're seeing something like a 90% compound annual growth rate in hydrogen for the remainder of this decade. So if you want a job, come and do one of these courses on hydrogen, because from my experience right now, we cannot get enough qualified people to fill the roles. And I'm not saying you can command your own salary out there, but certainly the jobs I'm seeing advertised are particularly well paid at the moment. So all to play for. It's still a troubled world out there. Lots of delays, project cancellations. We still have not got firm commitments from offtakes to say we will buy your hydrogen. And I think two areas I think to focus on. One is this baseload decarbonisation, given that 30% of our emissions are coming from industrial power generation, largely from gas. Therefore, we've got to do something about that. Never mind penalising car owners and truck drivers and even aircraft operators. It's all got to be worked on, of course. But equally, if we can take off some of these big ticket items, like the power sector, we're going to have a big win. To shift the power sector off natural gas and ensure we have got baseload power, we need some resilience in there. We need more hydro schemes. We need more batteries. And if we're going to continue with gas turbine generation, we are going to need more hydrogen than we have possibly conceived yet. So I think, hopefully, Alex, answers your question from some hydrogen perspectives. Loads more I could say, but I'm sure Marta's got loads of interesting stuff to feed into that as well.
Yes, please. Yeah, over to you, Marta.
Thanks. I mean, great points that have been made as always. I do wanted to reiterate a couple of them, especially on how the renewable sector is growing versus how emissions are still growing. Just to check on reality on exactly how we're moving forward, really, because although the renewable energy sector has grown massively in the last years, I think we're probably at sort of 30% of global electricity now that is delivered by renewables. So we can see there's still space to grow. Also, how do we grow? I guess I just want to come back to the point that I always try to make. I mean, being competitive on having solutions that are competitive in the market and moving towards solutions that are competitive in the market is our best entry into actually driving renewable energy forward and solutions that are green forward, because that is really what will make people across the world and companies across the world make the argument about moving towards renewables. If we can make them competitive, that's really where the investment will come through. And with the investment, we can deploy sort of these technologies at a fair scale much faster. On the other hand, we see that greenhouse gas emissions are still increasing. This is a function of, on one hand, population is still growing, and as John was saying as well, how we see that energy consumption is still growing. We are better in terms of carbon intensity and sort of energy efficiency and on how we use the resources, but we still are not there yet on peaking on the emissions and coming down to where we have to. I mean, we're around 1.1 degrees Celsius in terms of global warming. I guess we all know from conversations around Paris Agreement and COP that where we want to get to is 1.5 degrees Celsius. So we do need to sort of push further on action there, especially because the pledges and the targets that we've seen so far are not enough to get us there. So there is scope to do more. We are finally getting to a point where we're justifying competitiveness of these renewable energy technologies. So now we're at the point on how do we scale up, and how do we scale up quite at accelerated but very large scale as well. And what are the implications in terms of a global perspective of doing that? Because for us to scale up, we need land. And we all know that at some point land is limited. So how do we make sure that we get an approach that is a global approach on the best utilizing of resources where there's more space and we can produce it cheaply? We're also looking at that option versus where the demand is. How can we best utilize the resources globally on a systems thinking basis? Another area that I just want to point out, which is growing significantly, is carbon removals. And I know this is always slightly controversial, but I'm obviously not prioritizing this over any mitigation actions. But just from a neutralization perspective and where the companies are on their journey to net zero, it is important that they recognize that developing the projects now will actually get the removals required when we come closer to the sort of 2050 targets. And when I talk about removals, I don't necessarily just talk about carbon capture in sort of fossil fuel facilities. I'm actually talking more about the actual removals from the atmosphere, either on direct air capture or bioenergy capture bases, or even nature solutions. The reason why this is important is because, on one hand, all of the engineering solutions need quite heavy coordination and large infrastructure requirements. And two is because although we're on a pathway to capture almost, I think, around 600 million tons of CO2 per year, this is probably just 60% of what we actually need to get to that 1.5 pathway. So just to give perspective on where we are right now, but there's still so much that can still be done. And the same, I think, happens in terms of employment. With the evolution of all of these technologies, obviously it has brought a significant number of new jobs. But I think on a global scale perspective, we're probably at around 24% of the total jobs in the energy sector. So we can show there is definitely space to grow. And it's important also to note that the jobs in the energy transition expand beyond the energy production sector. So you don't have to be working in the energy production sector to be able to go into these courses and really understand how you can change within your company. I mean, decarbonization applies to all users, all companies, all services. And a lot of the times it's true that it means installing and getting through renewable energy projects or nature solution projects, but this will have to come within the user side as well. And therefore, it's important to acknowledge and understand through the courses exactly what the options are for the companies where people are already operating in. You don't necessarily need the new jobs, you can internally upskill. And there's a couple of reasons where it makes sense to internally upskill as well. One of them is that companies are currently going through a lot of regulatory obligations that are completely new to their core business. And it's definitely important that they become prepared to sort of how our company is going to respond to all of these ESG accounting and monitoring requirements. How are they looking to decrease the carbon footprint of the products that might not necessarily have to do with their core business? Also on an operational capability, I mean, some of these renewable energy technologies that we're applying to, for example, infrastructure assets like an airport, we need to upskill the workers to know how to utilize the equipment. We can't just put hydrogen at an airport and then the person that operates the ground handling equipment, they need to know how to refuel on hydrogen. What is the health and safety considerations around that? How does that change the mechanics and the practicalities of using these technologies on a day-to-day basis? This is something that's really important and across, I think, all our courses to really take on forward and understanding the upskilling has to be done now in terms of, or to also support the energy transition to build in the future. Obviously, we also have external upskill. I mean, there are new technologies that are required. There's a lot of R&D work that still needs to kind of go through specifically to a couple of hard to abate sectors where the technologies are either not there yet or not competitive yet. There was a question on the chat around AI and monitoring systems and how that can also support sort of the industry moving forward. But besides that, there's also sort of low carbon industrial sector equipment that needs to be developed, or even on sort of the green hydrogen economy areas that we can still develop more and across all of the sectors that we work in. And finally, I guess just in terms of efficient system building, we are basically redoing the energy system again, building new infrastructure. Can we have a better allocation of resources on a regional basis, but also on a global basis to push this forward? Can we look at opportunities to use waste heat from areas around the asset that we're decarbonizing? Or how do we best produce on-site renewable energy to make it more competitive and more accessible to consumers? Having this sort of approach around system building is quite important taking forward. And that is something that we can take out of all of the courses again, because it's important to understand all the options that we have, because actually different options, different types of energy solution, different types of carbon removals, all of them will interact with one single user. And therefore, it's important that people also have that sort of approach where they can understand how to have an overall perspective over the full renewable energy system.
Really well put there, Marta. I think systems thinking is so crucial. Just to provide an anecdote on another point you made, me and my transport vehicle world, we're getting questions from car dealers who are getting questions from their own customers for the first time who are asking, well, is my house suitable for a heat pump? They're not going to sell them the heat pump, but the customer is trying to understand, can they actually go electric, charge up their electric car from the solar panels on the roof? And is that all going to be feasible from their home, or are they going to have to use a public charger? This is all kilowatts, kilowatt hours, information that somebody from your local car dealership forecourt has never had to think about before. And so the blurring of systems is creating a real need for upskilling. So I hope that's an opportunity for everyone to engage with our courses. Really good answers. Thank you so much. I think there's a lot here we've already covered in terms of what the next steps and the trends are. But that's what we're going to come on to as the final question. What does the renewable energy sector need in terms of there's kind of key trends that are coming out in 2025? We have had a question about AI. We've had a couple actually. Just a quick flag that if you've got any interest in the courses, the best thing to do is to go onto the website renewableinstitute.org and have a look there. We do have a lecturer who's not joining us today, who does teach on AI. He's called Aidan. He's got AI in his name, but I promise he is a real human, not just a chat bot that we've created. So a quick quick thought on that. AI is obviously the big trend that is affecting all sectors at the moment. We had a question around the benefits of AI on driving technologies to support emissions reduction. Will they outweigh the extra emissions it causes? Lots of people thinking about this at the moment. I did see a little stat around how if you compare a search on Google compared to a search on Chat GPT, if you said where can I find amazing renewable energy courses, Google would use 5 times less electricity to find you that answer than ChatGPT would. So huge additional demand happening. We've seen that happen in series before. This isn't a new AI thing. We saw this with the move from CPU to GPU and the increasing power that computers are starting to take. My personal view is it's a big question for all these big tech companies that have set these amazing renewable energy targets or even went fully renewable with their data centers many years ago and now finding that their power purchase agreements aren't good enough. However, I don't necessarily think that's going to drive greater adoption of fossil fuels. I think it's more likely to build innovation around how grids work and potentially unlock new levels of technology development to so for in small parts of the grid where you can connect up a really heavy using data center, they'll be able to build a huge extra amount of base load perhaps for that region, for that province in that country, while also making sure that they can meet the potential demands of their country. It's far better for them to connect into a grid than to try and build their own microgrid and start trying to build AI businesses at the same time as building energy businesses. That's just my opinion and something you see quite a lot in the news at the moment, but a perspective on some of the trends going forward. I would just say, from an electric vehicle perspective, EV adoption is just continuing to grow in 2025. Where it grows and how it grows varies in every country. The same for all technologies, right? But for me, the big ones to watch are actually looking at what does China do in the rest of the world? What does that look like with partnerships in Germany? We saw a slight slowdown in the German automotive output as strategies have really quite struggled over the last year. But we're expecting that to really evolve and perhaps see more joint ventures on how you can actually bring in Chinese technology without bringing in tariff-laden Chinese cars into Europe. Interestingly, a UK perspective is that we're really doubling down on electric vehicles and will not put as many tariff barriers onto Chinese vehicles. So you might start seeing brands or at least technologies coming from China faster into parts of Europe that we didn't see happening before. The number one thing for me to watch is also commercial vehicles. We're starting to see the fleets that have used trucks quite heavily. They have started to adopt electric versions, building their total cost of ownership models the same way as people who run bus fleets. And they've started to see that it's making financial sense much sooner than they realized. Many are predicting that it'll take many more years to make the cost stack up to switch to batteries. Certainly, there's operational challenges, but we're starting to see the first demo fleets. Typically, you start with 5 vehicles in a fleet of 1,000. those first demo vehicles are proving the case, and we're starting to see that grow up to 7 to 10 times the amount of electric vehicles in a fleet within 12 months. So that's an exciting phase because we haven't seen that in heavy vehicles before. It might be replicating what we saw in vans and cars 5 to 10 years ago. The crucial thing for me is how do we integrate this with the grid? There's a lot of new technical protocols that are going to become mainstream around vehicle to grid technology. So another thing that I'm really keen to watch. And just to reiterate the point that Marta said, it all comes down to education. I've seen so many fleets that have tried to electrify vehicles the same way that they've been doing with diesel, but it does change your operations. It's an infrastructure game. You have to become a property manager. You have to become an infrastructure manager. It's not just looking at a spreadsheet of liters of diesel anymore. So huge opportunity there to get people upskilled into this world of electrification. But enough from me. I'm going to pass actually back to Marta. I'm just curious on one quick thing. A friend of mine runs a DAC, direct air capture company, and they've just released an end consumer website where you can go and offset with direct air capture. You can buy a kilogram of CO2 to be captured from him. That's Sirona Technologies in Belgium. So I'm interested to see, are we going to start to see that move into direct air capture happening like that in a kind of an end consumer world, like we've seen with offsets in the last few years? And any other future thoughts you have, Marta, before we finish off with the two Johns and Rob?
Well, first of all, that's quite impressive. DAC is extremely expensive to produce. Direct air capture is an interesting one. Obviously, I mean, in terms of the market of delivering removals, which is what they do, there's two big streams. There will be DAC. There is the bioenergy facilities where you can put carbon capture on and sort of store the carbon, which in a way are a bit easier because the infrastructure on the bioenergy is there. So we only need to kind of build on the rest of it. And then there's the nature solutions, afforestation and others that, if well monitored, and here coming the AI, the satellite imaging and all of that, are probably going to be much cheaper than a DAC solution. So how would all of those play out in a future market? And how does demand versus pricing around that versus reputational concerns around getting the best and high integrity carbon removals? How all of those drivers will play out on the demand for DAC versus an afforestation project. It's, I think, an interesting point to shaping the market in the future, really, and to understand how the market is going to evolve on that. The other thing that it's interesting about DAC, but that's also interesting about data centers, for example, is the sheer amount of energy that they require. I mean, DAC or data centers, the scale that we're talking about there is on the hundreds of megawatts of energy requirements. While if we go to sort of a medium regional airport, they need 10 megawatts of solar. So the upscale is massive. And it's massive for the user, meaning the DAC facility, the data center facility, but it's also massive for the energy centers that they require and for the backup energy that they require as well. So definitely an interesting point to see what happens in the future, but even more interesting to see how they can integrate more. I think there will be two big trends in the future. There's a big scale up on renewables. We're already getting to the point where technologies are competitive. So scale up, and further investment being pursued, solar, wind, BESS, and others, and also getting into new regional developments, new areas that there are areas that push forward the renewables, and there are new areas that are now looking into sort of just deploying large scale. And then there's the integrating more. So again, just coming back to the system thinking point, how do you integrate with energy centers around DAC or around data centers to enable those structures to come through in the future? How do you integrate that with community and nature? Because this is going to be a really, really important point in the future. I mean, you can't develop large-scale renewables if you don't have the community behind you. Everyone that does development knows that. You can get your project stalled by one person somewhere in a farm saying, no, I don't want a solar plant near my house because it makes noise. So community and nature is really important. And also the innovating around how we put the systems together, and innovating around the technologies, and especially how can we move that on a hard to abate sector and carbon removals. There will be a move towards how can we really push forward the aviation, maritime. I mean, you're in transport, so you know how difficult it is to decarbonize. Definitely a scale up, integrating more and innovate. I think those are my keywords for the future.
Great, thank you, Marta. I've just seen we're running low on time, but there is plenty of time to get the final thoughts from John, and Rob. So I'll go to John Wilson first, as I see you're not on mute. Some key thoughts from you for the future.
Yeah, thanks. Well, there's undoubtedly a move across many countries to large scale PV, usually in conjunction with storage and wind, and we've heard a lot of that. It will depend how fast that can be installed on investment. And of course, it doesn't just come from government, it comes from private investors. So the challenge is probably to make sure that it still looks an attractive investment. We know economically and environmentally it's attractive. We probably have no choice. But will the investors continue to put money into PV, storage, batteries, and so on? Or will there be challenges from the fossil fuels people who suddenly make some of their stuff look attractive as an investment? So that's one risk. It may not be too serious, but it does mean that and geopolitical challenges, like we're seeing in the States, we don't have time to go into that, can be counterproductive in a way. I think that PV and renewables in general have got a lot of momentum behind them. They're going to continue. And despite whatever administration comes into the States, they've seen the business sense of setting up giga battery factories, having EVs, all the new jobs it creates. So overall, I think it's okay. There are certainly some risks. If you look at what the UK is generating at the moment, it's about 42 gigawatts. And it's coming from, without going into too much detail, 40% of that is gas and about 10% is nuclear. And of course, we buy from outside. So wind and solar and biomass are something around about 40% perhaps. So it's shifting that. It's shifting the economics in that way. That's, in a case, the challenge. Some people say even in the UK, we won't meet our 2030 targets. And of course, it's up to pressure from the public as well as businesses to make sure we can probably put that up. Certainly what's looking at the moment is that we won't meet the targets at the present rate of increase. So there are a lot of things we need to do. But overall, the position is very positive for anyone looking for employment in the area because the demand is certainly exceeding supply. And as long as you've got the correct skills, you're probably guaranteed a job, although not necessarily in your small locality. That might be a problem. But overall, it's very good. Grid systems are going to need thousands of new jobs, not just replacing retired people. There's a lot of options. So taking one of the courses is undoubtedly the right step forward.
Great point made, John. Thank you. So on to John Clipsham, and then we'll give Rob the final word afterwards.
Right. Fortunately, most of what I was going to say has been already covered. However, in terms of jobs, don't worry because a lot of jobs are going to transition. If you are driving a taxi powered by diesel today, you're going to be driving electric taxi tomorrow. Your job is safe. So there's a whole part of this, not just about job creation, but job transitioning. And we need to be confident that jobs and livelihoods will be maintained. From a very selfish perspective, I now have a demand, and the sector has a demand for hydrogen engineers. We need competent people that can speak both electrons and molecules and articulate that space in between. And not to put too fine a point on it, those that have been through the courses that we offer are finding it very, very easy to take up those roles and jump in and drive hydrogen projects forward. So 2 more points. One, future energy system. Hydrogen is going to be essential if we are going to push beyond even 50%. If we're going to push to 75% and beyond, we are going to need something like hydrogen to do the heavy lifting and ensure we've got sufficient energy stored. And that's going to allow us, I hope, to deal with some of these big industrial decarbonisation challenges and wean ourselves off natural gas. So that's the points, but with one further thing I wanted to say, and I've not really had a chance to talk about transport. There's a real push on synthetic fuels right now. I would encourage everyone on this call to go and have a long, hard look at synthetic fuels and have a look at the full life cycle. And whilst there may be some carbon captured in there, the moment you combust that hydrocarbon synthetic fuel, your emissions are out there. And if you don't capture them immediately, that you're looking at 100 years plus before they're dealt with by the atmosphere. So is that kicking the can, or is that a really part of this transition solution? That's a personal view, but do feel free to put a comment in the chat and it'll get fed back to me, and I'm happy to engage on that outside the confines of this call. Thank you.
Thank you, John. And finally, we've got a couple of minutes left. Rob, over to you.
Oh gosh, 2 minutes. No pressure. Couple of things. Really interesting about AI and DAX. One of the things that's going to happen, that is already happening, is that as you transition to a renewable energy future, you land up with, at times, huge amounts of overcapacity. And and if you don't use that overcapacity, as happens at times in the UK, you have to switch it off, which is wasteful from a capital perspective. And so using whether you use that energy to make hydrogen or to directly capture carbon from the air, then that's one way of increasing the sort of effectiveness of your renewables, but also spreading it out and evening loads. And what this means is that the systems are going to become much, much more dynamic than they have been traditionally. And that's where potentially AI can come in, because it's going to help people manage grids as you have all of these different, whether it's loads moving up and down, or whether it's wind going up and down, or with solar going up and down, and managing that. AI could potentially help with that. And then AI can also help potentially at a smaller scale. So if you have something like a big wind farm, already we turn individual wind turbines to change the way the air flows through the wind farm. And so AI could potentially help you with that. Just looking at, and all of this is taking people to do it. And at the moment, there is over 13 million people employed in the renewable energy sector worldwide, according to ARENA, and they are split very evenly between the different technologies, and that is only going to do anything but grow. There's really no reason why it shouldn't. Whatever happens with fossil fuels, world electricity demand is going to go up, and it needs people who understand those technologies to work in those industries. And whether you're an existing engineer, it's really useful for you to understand how those technologies work and how they're going to affect the way that you work in the future. Or whether you are becoming an engineer or a solicitor or any other of the skills that we need, then understanding what's going on in those technologies is really, really useful to you, whatever your career is. Those are my thoughts.
Great. Thank you so much, Rob. And thank you everyone for joining us today for our webinar. We've come to the end. So I want to say a final thank you to John Wilson, John Clipsham, Rob Gwilym, Marta Zambuyo de Oliveira, and from myself, thanks very much for joining us, and see you again soon.